Um, so is there any, do we want to start off with any questions from before? Comments? Questions or comments from before? Anyone? So you're probably wondering what that title is on the screen there. That's not the name of the lesson in the book. The name of the lesson in the book for 1.4 is fitting models to data. And I told you we wouldn't be doing that. So, kind of in replace of that, something we need to emphasize quite a bit because there will be a fair amount of trigonometry that we're going to do this semester, that I would do pre-calc trig type review. And so if you're wondering, that's why that says 1.4 trig review. Excuse me, picked up a cold last week. Okay, so let me get rid of. Okay, so no questions. We will go right to trigonometry of important angles. So what we're going to do today is we're gonna let me get rid of this. We're going to fill in basically. We're going to fill in this chart using our knowledge of trigonometry. So what I've got here is all of the major angles. By major angles, I mean the quadrantal angles. The quadrantal angles are the angles at the quadrants: 0, 90, 180, 270, and 360. And then all of the special angles in each of the four quadrants. And those angles are brought on, I'm going to move this down a little bit, by two geometry theorems. So I really need you to kind of dip back into trigonometry, and you need to think of two special triangles. So first of all, we have the isosceles right triangle. So the two sides that are equal are also what form the 90-degree angle. And the other one is the 30, 60, 90 triangle. And each of them, I mean, in geometry, we know that these two sides in the isosceles right triangle are equal. So to make things, to start off with, we can call them any length we want. Let's pick a nice, easy one to pick, one. And using the Pythagorean theorem, we know that the hypotenuse would be the result of the Pythagorean theorem here. So we get 1 plus 1 equals c squared, 2 equals c squared, c equals square root 2. All right, and then here's one that not a lot of people remember normally, but in geometry, there's a theorem that says in a right triangle, the side opposite the 30-degree angle is half the hypotenuse. So the side opposite the 30-degree angle down here is half of the hypotenuse. And again, I could use 2 and 4 or 3 and 6, but let's pick a unit measure to make calculations a bit easier. So this missing leg over here, we can figure out again using the Pythagorean theorem. This is supposed to be plus 4. Hang on a minute. I got some sloppy work being done here. Let me redo this again. That was supposed to be an equal sign. Okay, let's try this again. My apologies. So we've got a squared, this being a squared plus 1 squared equals 2 squared. A squared plus 1 equals 4. A squared equals 3. A equals square root 3. So those two triangles and the relationship between the sides give us all of these answers between 30, 45, 60, all those non-quadrantal angles in the chart. I'm sure you know this, so anyway, based on that, we should be able to run through these. And you know that your basic measures that what? Sine is equal to the opposite, the side opposite divided by the hypotenuse. The cosine is the leg adjacent divided by the hypotenuse, and the tangent is the leg opposite divided by the leg adjacent. So for the time being, I just want to take these first three in the chart, sine, cosine, and tangent, based on that. And let's see what we can find. So the other thing I always taught my students is behavior charts. So you should be able to, let me just go off to the side here and show you what I mean by that. So for each of the functions, we have, let's try that again. So, you know, you got the point here, 1, 0, point here, 0, 1, and so forth. And as you go around in, for example, the sine function, what? It's opposite over hypotenuse. Now, in this problem right here, we draw a right triangle here, we can see that what? The hypotenuse is, it's basically the radius, and that's going to be 1. So all we got is this side divided by 1. So as that side gets bigger, it's going to be positive because it, you know, this is this heavy segment I'm drawing here. This has to represent the sine. So as the angle goes around in a counterclockwise manner, that's going to be getting bigger. So positive, and it's increasing. Over here, you know, it's still positive because it's above, but now it's going, now it's getting from this value over here, it's going down. It keeps getting lower, so it's decreasing. Down here, the sine is now going to be dipped below the x-axis, and therefore it's going to be negative. And in fact, down here, it's going to be -1. By the way, I should have started off at, here it's going to be 0, here it's going to be 1, here it's going to be 0, here it's dipping down, it's going to be negative, and it's decreasing. And then finally in the fourth quadrant, we've got triangles that look like this, and you can see that it's negative, but it's increasing because it's getting tinier negative. So anyway, behavior charts, that's what I mean by a behavior chart. So with that in mind, we can go back here and start filling things in. The sine of 0, the height of that thing is at 0 is 0. Get the pen to work. At 30 degrees, now we are back in this chart, opposite over hypotenuse, we should have 1/2. At 45 degrees, now we're over on this triangle on the left, 45. These are both, of course, 45s. Sine of 45 is 1 over the square root of 2. By the way, some teachers will, and that may be yours, may have emphasized that 1 over the square root of 2 needs to be rationalized. You multiply top and bottom by square root of 2, and you get square root of 2 over 2. That's fine. I like to leave it this way because then I can really see in the basic triangles what over what. But either one is fine. The sine of 60, now we're back over here again. Square root of 3 over 2. 90, now we're back on the behavior chart. We're at full height. 1, 120. Now it's going down, but we're still going to be positive. And 120, you always want to use your nearest x-axis angle as your reference. 180 minus 120 is 160. So the sine of 120 should be the same as the sine of 60. Notice these two are identical. 135, that's 45 degrees from the nearest x-axis. So that's going to be, again, the same as the sine of 45. 150 is a 30-degree angle. So you notice this has gone up and now it's gone down. And 180, we're back to 0 again. Okay. So now we go into the third quadrant. The sine of 210 is a 30-degree angle in the third quadrant. It's how far from the x-axis? 30. So the sine of 30 is 1 over 2. But because we're in the third quadrant, that's got to be a negative. 225 is a 45-degree angle in the third quadrant. 45, 1 over the square root of 2. Again, the SIGN of the SINE is negative. By the way, so I can't say the sign of the sine because they're homonyms. So you'll hear me spell that out. 240 is a 180 plus 60. So sine of 60 square root 3 over 2. And because it's in the third quadrant, the SIGN of the SINE is negative. 270, we're all the way down, fully stretched out below, as our behavior chart showed here. Let me just quickly show you. Our behavior chart, we are all the way down to the bottom, and so, we're at that -1 down there. Okay? 310. So now we're in the fourth quadrant, and I'm sorry, 300. And 300 is a, 60 degrees from the nearest x-axis. The sine of 60 is the square root of 3 over 2. Because we are down in the fourth quadrant, we know that sine is negative. 315, 45-degree angle. So the same as the sine of 45, we have a negative again. And 330 is just 30 degrees from the x-axis. So that would be 1/2, and that would be negative again. And finally, we're up to 360, which is the same as 0. And the sine has no height at that point. Okay, cosine, leg adjacent over hypotenuse. So now let's just go back and run that real quick. A behavior chart for cosine. Okay, cosine. See if I can draw some decent. Okay, so again, this is a unit circle. But this time we are doing cosine. Now the cosine is the leg adjacent divided by the hypotenuse. So if we pick a triangle in the first quadrant, this guy right here divided by the hypotenuse. And the hypotenuse is always going to be 1. So now we're looking at the horizontal coordinate of this. And when you start off on the right, that's going to be, when that's all the way collapsed down, it's full width right, so that's 1. Here it's going to be 0. Here it's going to be -1. Here it's going to be 0 again. From 1 to 0, it's decreasing. That's positive. From 0 to -1, it's negative, and it's decreasing. From -1 to 0, it's negative, and it's increasing. From -1 up to 0, and then from 0 to 1, it's positive, and of course, it's increasing. So we've got this situation going on. Keep that in mind. So now as we start filling out the cosine, Cosine of 0. That's full width right, so that's a 1. Cosine of 30. Square root of 3 over 2. You look at the triangle right up here on the right, up above, these 30, 60, 90, the leg adjacent to the 30-degree angle is that square root of 3 over 2. 45, cosine is 1 over the square root of 2. 60 degrees, cosine, 1/2. And 90 degrees, cosine has shrunk down to 0. 120, this is a 30-degree angle in the second quadrant. So 30 degrees hang on just a second. I just want to check something. Yeah. So the cosine of a 30-degree angle is 1/2. I'm sorry, that's a 60-degree angle, 1/2. But because it's 120, because it's to the left of the y-axis, this is now negative. Cosine of 135, 45-degree angle, 1 over the square root of 2. But again, because we're in quadrant 2, it is negative. 150, that's a 30-degree angle. So the cosine of 30 is the square root of 3 over 2. And again, we are in the second quadrant, cosine is negative. At 180, the cosine is stretched all the way out to the left, -1. Okay, 210. That's a 30-degree angle in the third quadrant. Cosine of 30, square root, cosine of 30 is this, hang on a second. Cosine of 30 is the square root of 3 over 2. Because it's left, negative. 45-degree angle, 1 over the square root of 2, negative. 240, that's a 60-degree angle in the third quadrant. 60 is 1/2. Cosine of 60 is 1/2, and that's negative. And then finally, 270, the horizontal coordinate has increased to 0. All right. 300 degrees is, now we're in the fourth quadrant. We're 60 degrees away. Cosine of 60 is 1/2. And because we are right, this is now a positive. 315 is a 45-degree angle from the nearest x-axis. And that's 1 over the square root of 2. Again, positive. 330, a 30-degree angle from the x-axis. Square root 3 over 2. And finally, 360, cosine is full width right again, so it is 1. All right. So let's take a look at tangent. I bring this down so we can see our two basic triangles up on the top. The tangent of 0 degrees. Oh, we got to think of our quadrantal line. We should take a look at, we need to make another behavior chart. Okay. So now let's make a behavior chart for our tangent. So again, we have 1, 0, 0, 1. So now what we need to do is think about, in geometry, what's a tangent? It is a line that just barely touches a circle at one point. So if that's our tangent line, then when we draw an angle, we need to extend it until it hits that. This length from here all the way up there, you know, from the origin all the way up there, that's the length of the tangent. So at 0 degrees, I'm sorry, I apologize. we need to redo something here. The tangent is this length right here. The tangent is the length along that tangent line. So at 0 degrees, that's going to be a height of 0 because that line will be collapsed. We get up here. So this length gets, I mean, we wind up with an infinite length here. So we have to call the tangent at 90 degrees, undefined. When we get back over here, we're back to 0 again. And down here, we're at undefined. So in between, the tangent is positive and big time increasing. It's undefined, this huge thing. And okay, over here, you know, so we're going to have, when you have an angle over here, we have to back it up. And so the tangent will be down below, so it's going to be negative. And it's, again, increasing. Weird thing about the tangent is it's forever increasing, all 4 quadrants. You notice how before in our behavior charts, you know, like with the sine, we had 2 increasing quadrants, 2 decreasing. With the sine. With the cosine, 2 increasing, 2 decreasing. So it's weird with the tangent, which I haven't labeled yet, tangent. All 4 quadrants are increasing. That is really strange. Sine over here is from 0. So it's increasing. What do you think here? Yeah, down here it's going to be negative and it's increasing, and over here it's positive and increasing. Because when you draw a triangle down here and you back it up, the tangent will be above. So we still have positive, positive, negative, negative. So you're going to notice that in these behavior charts, the sine had 2 positive quadrants, 2 negative quadrants. Cosine had 2 positives, 2 negatives, and so does the tangent. Positive in the first and the third, negative in the second and the fourth. Okay, I know that's awfully quick, but at least we have something to go by. Let's keep it so we can see our 2 triangles. All right, tangent of 0 degrees. If you remember, your behavior chart is, it's zeroed out, no height. 30 degrees, the tangent of 30, 1 over the square root of 3. The SIGN of the tangent in the first quadrant, positive. Okay, 45 degrees, 1 over 1, 1. 60 degrees, tangent of 60, square root of 3 over 2. And 90, we have no choice but to say undefined. And the reason, I mean, so the question is, if you go back to this behavior chart of the tangent, this distance of the line until it hits the tangent line, and when it's vertical, it's never going to hit it. It's parallel, and so I can't give it a measure, and it's undefined. Excuse me. All right.
Professor,
120. Yeah, question?
isn't the square or the tangent of 60 square root of 3, not square root of 3 over 2?
Yes, it is. Thank you.
Yep.
Yeah. Square root of 3. So we were doing 60 tangent square root of 3 over 1, which is square root of 3. Thank you. Okay, let's get that fixed. Okay, now 120. That's to the nearest x-axis, that's a 60-degree angle. So again, it's the square root of 3 over 1. 135 is a 45-degree angle. But because we're Oh, because we're in the second quadrant, the tangent is negative. 135, we're in the third quadrant. Tangent of 45 degrees is 1. 150 is 30 degrees from the nearest x-axis, and the tangent of 30 is 1 over the square root of 3. Because we're still in the that's supposed to be the square root of 3. Having a little trouble with the pen here. Let's try that again. 1 over square root 3. There we go. And that's still negative. And 180, the tangent's back to nothing because when it's a horizontal line, and when you back it up, it doesn't make any height with the tangent line. Okay, 210. 30-degree angle in the third quadrant, so it's going to be positive. And tangent of 30 is 1 over the square root of 3. 225, that's a 1. And because we're in the third quadrant, positive. 240 is a 60-degree angle. Tangent of 60 is square root 3. And then finally at 270, we're undefined again. All right, 300 degrees. We are now 60 degrees from the x-axis, so that's going to be square root 3. But because we're down in the fourth quadrant, that's got to be a negative. 315 is a 45-degree angle, so tangent of 45 is 1. Again, we're in the fourth quadrant. Tangent has to be negative. And finally, 330 is a 30-degree angle, 1 over the square root of 3, because it's in the fourth quadrant, negative. And lastly, 360, you're back up to a tangent of 0. Okay, so there's our 3 basics. Now, the way I taught this to my students, really, these bottom 3 below the horizontal line are what? You have to learn your reciprocal functions. And what? The reciprocal of the sine is the cosecant. That's the reason I put it first. Sine, cosecant. Cosine, the reciprocal of the cosine is the secant. And the reciprocal of the tangent is the cotangent. So I've positioned these in order so that I just got to erase some stray marks made here. So we should be able to now just go up to our chart and do reciprocals. Okay, where we can. Of course, you can't take the reciprocal of 0. So we have to say undefined. Reciprocal of 1/2. Reciprocal of square root of 2. Now here again, if you said if you said square root of 2 over 2, then you're going to have 2 over the square root of, you know what I mean? You're going to use a different answer here. 60 degrees, square root of 3 over 2. And the reciprocal of 1. Okay, reciprocal of 2 over the square root of 3. Zero is reciprocal again. I'm having a little trouble with my marker. Let's try that again. Okay, this should be undefined. I'm just using the reciprocals of that top line up there. Of course, reciprocals do not affect the sign. So the signs, if it was negative, the reciprocal has to be negative. Okay, secant. That should be the reciprocal of the cosine. Reciprocal of 1 is 1. Reciprocals. So this is what? -2, undefined, 2, square root 2, 2 over square root 3, and a reciprocal of 1, 1. And finally, the cotangent is the reciprocal of the tangent. Again, you can't take the reciprocal of 0. By the way, that secant of 30 is not clear. It should be 2 over the square root of 3. Okay, so now reciprocal of that, square root 3, 1, 1 over square root 3. Now, the reciprocal of undefined is, you can't take the reciprocal of something that's undefined, but I do know that the reciprocal works both ways. And when I take the reciprocal of cotangent, I should get the tangent. So that's got to be a 0. -1 over square root of 3, -1, negative square root 3, again undefined, -1/2. No, that's not true. Got in the wrong spot there. Negative square root 3, this is. Okay, 1 over square root 3, 0, -1 over square root 3, -1, negative square root 3, and undefined.
For the cotangent of 210, why is it negative? I thought it would be positive. Root 3.
It's because it's I made a mistake.
Okay.
You are absolutely correct. It's the reciprocal of 1 over the square root of 3, which should be positive square root of 3. Thank you for noticing that. Yeah, and I know this is kind of crammed in here, but I thought I wanted to show it as a unit. So the point of this is you need to know trigonometry well enough to be able to fill this chart out without a calculator. And yeah, you can make, I would, if I was doing this chart, I would make these 2 drawings just to nail down, oh yeah, my 2 special triangles, the isosceles right and the 30, 60, 90. Okay, I should be able to do that. You also have to have some knowledge of the behavior charts. By behavior charts, I mean this general layout, that the sine represents the vertical coordinate of a right triangle that's rotating. The cosine represents the horizontal coordinate of a right triangle that's rotating. And the tangent has to do with this new tangent line drawn in, and the hypotenuse of the triangle extended out to that length represents the tangent. So anyway, put that all together and you should be able to come up with that type of thing. So if you can't do that, we're gonna have to fill that hole. Now there are some links. If you look on, let's see if we can find this review. Let's go back to our site. Oh, I know. If you go to the core exercises, and when the core exercises come up, you'll see these 2 links in there. And if you control click on those, it'll open up this site on the WLC website, and that goes through some of the basics of what we just went through. And if we go back to that one more time, the trig you'll need for calculus. There's also another page on the WLC website. Yeah, it just got, it goes through all of the basics of trigonometry. So anyway, you may want to go to those. Okay. Now, let's talk a little bit about identities. Okay, so what's an identity? An identity is something that is always true. Okay, so when we take a look at trig identities, here are the ones that I expect you to have memorized. Okay, we already know the reciprocal identities, the sine and the cosecant, cosine and the secant, and the tangent and the cotangent. So I should really put a line there. So, hard to draw straight sometimes. Let's make that different color. So those are the trig identities. Then these three are called the Pythagorean identities. And these two down on the bottom are called the ratio identities. So let me explain. The Pythagorean identities, yeah, I mean, besides just having them memorized, some basic, if we go back to the behavior charts here, okay, let's make our own. So we've got this, again, we've got a situation that goes like this with a unit circle. And if you take one of those triangles, a right triangle, as you rotate this angle theta around and, you know, go in this direction. So this, the horizontal coordinate, that represents the cosine. The vertical coordinate, that represents the sine. And this is, the hypotenuse is, as you can see in this unit circle, is forever stuck at 1. So if you take the Pythagorean theorem, yeah, except we got a notation issue. Let me get rid of that. So if you take that and square it, and the other leg is the sine of theta, and square that, you're always going to get 1, the hypotenuse squared. So we write that like this in trig. And that's one of the Pythagorean identities. Do you see why it's called a Pythagorean identity? Because it comes from the Pythagorean theorem. Let me show you another one of those. Let's take the tangent. So the tangent. Get my pen. Okay. So this is the tangent. And this from here to here is 1. And this, even though you don't know it yet, that's the secant. You may know it. I don't know. Secant theta is that hypotenuse. And if you take the one leg tangent plus the other leg squared, that should equal the hypotenuse squared. And I half wrote that in the other notation. Tangent squared theta plus 1 equals secant squared theta. And Just coming back to our identities here. That's this middle one, tangent squared plus 1 equals secant squared. And there's another one for the cotangent. And anyway, then two very handy ones are tangent equals sine over cosine. I mean, I don't know if I probably don't need to show you that, but you've got, so there are many others. There's a double angle identities. There's half angle identities. I mean, there's an infinite number of trig identities. Okay, these 8 we have here, 3, 6. These 8 are what I would call the basics, and you would want to have these handy as you navigate trigonometry. Excuse me. Excuse me, please. Boy, that was awfully quick. That was like a race from start to finish. Hopefully that's all looking pretty familiar. If it looks even a little bit like you might need a little firming up on that, go to those links. And that, you know, if you go to that, where were we again? I was when you come down to core, if you click on core exercises on the main site, you'll see there's a couple links to the WLC trig review. Okay. So I guess technically we don't have any assignments, but you know, you should be looking at the 1-5, because that's what we're going to be doing tomorrow. Any questions? So I'm sorry if I raced through that too fast, but I guess I could have skipped it completely. I was thinking it's pretty doggone important, and hopefully you've had a good course in trigonometry. Now the only thing I worry about is that you may have been with a pre-calc teacher that taught trig from a calculator viewpoint, which is basically a mortal sin, in my opinion, because it would mean that you didn't get the trig you really needed for pre-calc. So anyway, I doubt if that was the case, but every once in a while you'll see a pre-calc teacher that's totally wedded to the calculator and don't make you do enough manually to really get the basics. So just be sure that you're not one of those. If you are, it can be, we can remedy it, but it's going to take some time and some work. Does anybody have any closing questions or something to bring up? Wow, so quiet. Well, thank you for your attendance, and I will see you tomorrow.